Questions on the homework? Questions on the homework side before we get started? Number 10? Not a polynomial? Yeah. Because if it's not one, we just say it's not one. Number 10. Yeah, because it's not a polynomial function. Because the error was what? They said it was, and it's not. What we're looking at today is addition, subtraction, and multiplication of polynomial functions. So the first thing we're going to do is add two polynomial functions vertically. So when we add them vertically, we're going up and down. So we'll put this one first. 3x cubed plus 2x squared minus x minus 7. So we start with the biggest term, which in this case is our x cubed term, followed by x squared, x, and then our constant term. If the one on top is missing any term, we'd leave a space just to make room for it. The second one we're adding to it, we're going to put the like terms underneath it. So we'll put the x cubed term, which is just x cubed, under 3x cubed. We'll put the negative 10x squared under our x squared term. Since we don't have an x term, we won't put anything under the negative x. And we'll put the plus 8 under the 7. We line our like terms up so that when we add them together, we can simplify this a little bit easier. So the first thing we're going to add is 3x cubed and x cubed. 3x cubed plus x cubed is 4x cubed. Then we move over. 2x squared plus negative 10x squared. 2 plus negative 10, 2 minus 10 is negative 8x squared. Now since we don't have anything to add to negative x, it just stays negative x. And negative 7 plus 8 is what? Questions on this here? Adding two polynomials vertically is a little bit different than what we're used to, because we're used to, some ways, yes, adding them horizontally. Because when we add two vertically, we have parentheses around the first plus parentheses around the second. Now, with addition, we can just drop the parentheses. We don't have to worry about our sign changes, because with addition, none of the signs will change. Because since there's not a sign in front of our first set of parentheses, we can just drop them. Since we're adding the second one to it, the signs stay the same, so it'll still be negative 5y squared, positive y, and negative 4. Unfortunately, we can't because we need a value. It needs a value for y. Here, y does not have a specific value. And then it'll set y as 0. Yeah. At this point here, we can just rearrange it with the like terms next to each other. Now 9y cubed doesn't have any other like terms, but our 3y squared and negative 5y squared, we can put them next to each other. Plus 3y squared minus 5y squared. Here we have our negative 2y plus y. And lastly, we have our plus 1 and minus 4. And last but not least, we can combine our like terms. So we have 9y cubed. 3y squared minus 5y squared is negative 2y squared. Negative 2y plus y is negative y. And 1 minus 4 is negative 3. That's it. One. Yeah, plus 1 minus 4. It kind of got squished in there a bit. So we're just combining like terms at this point. Questions on this here?
When was that homework due for last week?
Get it in sometime this week, next week. Mm-hmm. So let's do one more of these here. We'll do it horizontally. 2x cubed plus x squared minus 3x plus 4. Here, we can add these two together. Now, we can drop the parentheses with both because, well, with addition, the signs are not changing. Now, at this point here, we can combine like terms. Well, our first set of like terms are 2x cubed plus x cubed. 2x cubed plus x cubed is 3x cubed. X squared plus 7x squared is plus 8x squared. Negative 3x, there are no other like terms with it, so it's just negative 3x. And lastly, 4 minus 2 is plus 2. So we can write the like terms next to each other and then combine it, or at this step here, we could go on and combine our like terms.
So what's the difference in this one and
So this here is technically vertical, because up and down. This is horizontal. So even though this one said vertical, we just did it horizontally.
so just
Preference, yeah. Mainly, that's all it is. Questions on addition? Let's look at subtraction. So with subtraction, we'll have the numerator, or the first one listed here first. So our 2x cubed plus 6x squared minus x plus 1 on top. On bottom, we'll have the 8x cubed minus 3x squared minus 2x plus 9. And for this problem here, we want to subtract. Whenever I do this vertically, I do put the sign between each of the like terms as a reminder of what we're doing. We're subtracting these. So we have 2x cubed minus 8x cubed. Our 2 minus 8 would be negative 6. We still have our x cubed. Our next one, 6x squared minus negative 3x squared. The negative and negative would make a plus. So 6x squared plus 3x squared would be plus 9x squared. Our negative x minus negative 2x. The negative and negative would make a plus, telling us that we have negative x plus 2x, which would be plus x. And lastly, 1 minus 9 is negative 8. So subtracting vertically does help us with some of the signs, making sure we do have the correct signs. But again, I think we're a little more used to doing these horizontally than we are vertically. Questions on this one here? We ready for the next one? So we're going to do this one horizontally. So we'll have our 3z squared plus z minus 4. And our 2z squared plus 3z. Not plus. Okay, I'm going to rewrite this. I'm just going to rewrite it. 3z squared plus z minus 4. And we're subtracting from it 2z squared plus 3z. I don't know why I almost multiplied them together. But we're subtracting these two from each other. Now the first set of parentheses, because there's not a sign in front of it, we can just drop the parentheses, telling us that we have 3z squared plus z minus 4. Now because the second set of parentheses has the minus in front of it, we're going to have to distribute the negative through, giving us negative 2z squared minus 3z. Now for this one here, we can put the like terms next to each other. 3z squared and our negative 2z squared. Z plus z minus 3z. 4 doesn't have a like term, so it's just minus 4. Now at this point here, we can combine our like terms. 3z squared minus 2z squared is z squared. Our z minus 3z is negative 2z minus 4. Questions about this here? Questions on any of this so far? Yeah. Y'all have done this in Algebra 1. We just didn't do too many with higher degree. It's a little bit of a refresher. So, yeah. We need to see another example of subtraction. We feel good with subtraction? Yes. And the biggest thing with subtraction is making sure when we subtract, whichever one we're subtracting, we do distribute that sign through to keep the signs correct. All right. What we're going to look at next is multiplication. Now we can do multiplication vertically and horizontally. We're just going to mainly look at horizontal. Because we multiply horizontally, we're just distributing our terms. So we'll start off with negative x squared. We'll distribute it through our second term. So negative x squared times x is negative x cubed. Negative x squared times negative 3. Negative and a negative make a positive. And 3 times x squared is, well, 3x squared. So we've multiplied through with the negative x squared. Now we'll move on to the 2x. 2x times x would be plus 2x squared. And 2x times negative 3 is negative 6x. And lastly, we do the same thing with 4. 4 times x is going to be plus 4x. And 4 times negative 3 is negative 12. Questions on this here? Now the nice thing with this problem is that the like terms actually ended up being next to each other. Our x cubed term doesn't have any like terms, so it just stays negative x cubed. We have 3x squared plus 2x squared, which is plus 5x squared. Negative 6x plus 4x is negative 2x minus 12. And that is it. Questions on this here? Are you ready for the next one? Y plus 5 and 3y squared minus 2y plus 2. So again, we're going to use our distributive property. The first thing we can do is multiply through by y. Y times 3y squared is going to be 3y cubed. Y times negative 2y is negative 2y squared. And y times 2 is plus 2y. And once we finish distributing the y, we can do the same thing with the 5. 5 times 3y squared is plus 15y squared. 5 times negative 2y is negative 10y. And 5 times 2 is plus 10. Questions on this here? Now, unlike the last one, our like terms are not next to each other, but we can still combine them. First one we have is 3y cubed. So it goes first because we do try to keep this in standard form. Variable with the biggest exponent goes first. Our next one is y squared. We can put them next to each other, or we can go on and combine them. Negative 2y squared plus 15y squared plus 13y squared. Then we have 2y minus 10y is negative 8y. And lastly, we have our plus 10. And that's it. Questions on multiplication? You feel comfortable with multiplication? All right. Let's look at this one here. We want to multiply x minus 1, x plus 4, and x plus 5. One more. Yep. We skipped a few. Since you all feel comfortable with those, there's no real reason to continue doing more of them if you all feel comfortable with them. Now, when we multiply three things together, it's not a whole lot different than multiplying two. It's just that we have to pick which ones we want to multiply first. I can either do the x minus 1 and x plus 4 first, or we can do the x plus 4 and x plus 5 first. Or if we wanted to, we could multiply the x minus 1 and x plus 5 first, and then multiply the x plus 4 second. Most we'll just do the first two here. And we can do that first. We can multiply the x minus 1 and x plus 4 first. X times x would be x squared. X times 4 is 4x. Negative 1 times x is negative 1x. And negative 1 times 4 is negative 4. Now this one here we did leave the parentheses because we do have to do another multiplication once we're done. Now at this point here we could go on and start multiplying through, but I would highly suggest if there are any like terms after you do a multiplication, combine them before moving forward. Because here, 4x minus x is 3x. And it'll make it a little bit easier to work with. And once we have it simplified, we're just going to multiply again. X squared times x is x cubed. X squared times 5 is plus 5 x squared. 3x times x is plus 3x squared. 3x times 5 is plus 15x. And lastly, negative 4 times x is negative 4x. And negative 4 times 5 is negative 20. Last thing we need to do is combine like terms. X cubed doesn't have any like terms, but we do have 5x squared plus 3x squared, which is positive 8x squared. Negative 15x minus 4x plus 11x, and then we have our minus 20. And that's it. Mm-hmm. 11x. So multiplying three terms together is not really any different than two. It's just we do two together, simplify, and then do it again. Questions on this here? I feel pretty comfortable with these here. Now there are some special product patterns. The main one, the sum and difference, is really the difference of perfect squares. Because if we have two things multiplied together, and the only thing that's different is the sign in the middle, it's kind of our difference of perfect squares. We're just going in the other direction. Because here, we're saying that x plus 3, x minus 3. Well, x squared minus 9 is a difference of perfect squares, so it factors x plus 3, x minus 3. There's nothing saying that we can't go the other way around. X plus 3 times x minus 3. Square the first term, square the second, and we get our terms. We haven't really talked about the cubes of a binomial or too much of squares of binomials, but those are kind of shortcuts. Now looking at this first one here, 4n plus 5 times 4n minus 5. So this is our sum and difference. Difference of perfect squares. So what it's saying is that we could square the first term, which is 4n. 4 squared 16. N squared minus 25. It's kind of a shortcut way to do this. Now if we don't see that, that's fine. But if we multiply this out, 4n times 4n is 16n squared. 4n times negative 5 is negative 20n. We do the same thing with 5. 5 times 4n is positive 20n, and 5 times negative 5 is negative 25. At this point here, we can combine like terms. These two will cancel, telling us that we have 16n squared minus 25. Both will get us to the same place. One's just a little bit quicker. Questions on this here? If we look at the next one, 9y squared minus 2, the square is just telling us it's being multiplied by itself twice. So it's really just saying that we have 9y minus 2 being multiplied with 9y minus 2. And at this point here, we can rewrite it out and then distribute our terms. 9y times 9y. 9 times 9 is 81. Y times y is y squared. Our 9y times negative 2 is negative 18y. We'll do the same thing with negative 2. Negative 2 times 9y is negative 18y. And negative 2 times negative 2 is plus 4. Combine like terms, telling us that this is 81y squared minus 36y plus 4. And that's it.
So is there no shortcut?
It ends up being a squared plus 2ab plus b squared. So there is a shortcut to them. But sometimes it's a little bit easier to work it out. And really, we're not going to look too closely at C, but any binomial that is put to a power actually does have a set theorem that works. And that's what this is here, the Pascal's triangle, the binomial expansion. Because for any one that we have to a power, we can actually use this here. The triangle itself is actually derived pretty easily because we start off with 1, 1, 1. The outsides of the triangle will always be 1. Each new row will always start and end with 1. What's interesting is if we add the 2 from the previous row, kind of making a diamond or an arrow, they add together. So our 1 and 1 give us 2. Here, 1 and 2 give us 3. 2 and 1 give us 3. We have 1. The next row, 1 and 3 give us 4. 3 and 3 give us 6. 3 and 1 give us 4. 1. And it's interesting, if we did the next one, we'd have 1, 6, 15, 20, 15, 6, 1. And we could keep going from here. 1, 7, 21, 35, 35, 21, 7, 1, and it keeps going on. And it gives us a way to factor, or really multiply out, a term being multiplied by itself. And that's how we get the numbers in blue on the binomial expansion. Now the a's, whatever the exponent is, so here 5, a starts out as 5 and then decreases by 1. 4, 3, 2, 1. It's not listed here, but the last one would be a to the 0. Anything to the 0 power is 1. So we don't write a to the 0 because it's just a multiplication of 1. So it's not there. Interestingly enough, b for the first one here starts off at b to the 0, but it's also 1. And it increases in power. Because then we have b to the first, b squared, b cubed, b fourth, b to the fifth. And this is a way to factor or expand any binomial to a power. But it's not necessarily necessary because we can do it by hand and multiply it by itself 5 times and get to the same way or same expression as using this here. But either way, that's all we're doing today.